Lastly, we will discuss the operation of a three-phase full bridge inverter with resistive load using different control techniques. I will start with the inverter controlled by the 120-degree conduction mode. In this video, I will show you how to sketch two phase voltages, which are red and yellow voltages, and one line voltage, which is VRY. For the first 60 degrees, we can see S1 and S6 will turn on. Hence, the equivalent circuit becomes like this. To analyze the circuit with ease, we need to reconfigure the circuit. As a result, we can have this equivalent circuit when S1 and S6 turn on. Since both resistors have the same value, hence VR and Vy can be replaced to Vt. By applying KVL, the voltage equations can be derived as follows. According to the equations, the amplitude of VR and Vy is half of the supply voltage. Nonetheless, based on the equivalent circuit, both phase voltages have opposite polarities. Therefore, VR is equal to Vs divided by 2 and Vy equal to negative Vs over 2. Meanwhile, the line voltage is equal to the supply voltage. Hence, we can sketch the voltages as follows. Next, we consider the time interval between 60 degrees to 120 degrees. As we can see, this time S1 and S2 will turn on. Eventually, we can sketch the equivalent circuit like this. And we reconfigure it to become like this. According to the circuit, Vy is equal to 0. Next, by applying KVL, we can see both VR and VRY are equal to half of the supply voltage. Thus, the waveform of all voltages can be sketched as follows. Lastly, we consider the time interval between 120 degrees to 180 degrees. This time, S2 and S3 will turn on and the equivalent circuit can be drawn like this. From the circuit, we know that VR is equal to 0. As usual, Vy and VRY can be found using KVL. Based on the voltage equations, we can sketch the waveforms as follows. Eventually, according to the half-wave symmetrical, these wave shapes will repeat with alternate polarity. As a result, the output voltage waveform of the three-phase inverter will look like this. After watching this video, you may try the same approach to sketch the output voltage of a three-phase full bridge inverter with the 180-degree conduction mode. For the PWM method, typically, we will apply the bipolar PWM control technique. To generate the control pulses, we need 3 reference signals and 1 carrier signal. The reference signals have the same amplitude and frequency with the desired 3-phase output voltage waveform. Control pulses generated by comparing the signals will be applied to the top switches. Meanwhile, the bottom switches will be controlled using the inverted control pulses. Thus, the top and bottom switches at the same leg will not turn on simultaneously.